So today we are moving on to a new chapter. So it'd probably be best for you to have your Chromebook out, open to 4.1.1.
The one day I don't have on my Chromebook. The one day my Chromebook's going to charge. Every day. Zach, that's every day for you. I know for you. I know. Who's Greenville? We play Owen Tangy Orange Saturday,
Mm-hmm.
and out of all the Owen Tangies, they're supposed to be the best with like sports.
I've never seen an Owen Tangy kid that could dribble a ball though, ever in my life, ever.
I have no idea.
Seen
It's been so long.
Owen Tangy, we're about to.
All right. So
That's terrible, bro.
No.
No.
we've already compared triangles before by using similar triangles. And to see also if they were similar, were they also congruent? So they were congruent if they had their common ratio was 1. So now we're going to look at slope triangles. So we're still dealing with right triangles. I told you guys those weren't going away. So it's basically for now going to be looking at the hypotenuse. And the hypotenuse is going to create our slope. So how do we define slope? Well, what letter do we use for slope? No, that's for speed. Yes, M.
Why M? Why not S?
That's a good question. Well, S is speed. No, these. Yeah, S is for speed. And slope is the change in y over the change in x. So how much does this line change in the y direction versus how much does it change in the x direction? So that's slope. So we need to know that to do what we're doing today. And we start off by looking at the Leaning Tower of Pisa. So people come from everywhere to look at this tower. Since the day it was built, it's been leaning. It was built in the 1100s, so it keeps tilting towards the south, and it's always at risk at falling over. So if the angle of the slant ever falls below 83 degrees, so it's talking about this angle opposite of the right angle, then the tower is going to fall down. So engineers watch it all the time. They know that at this point A, it is 50 meters off of the ground. And this triangle that we're going to deal with. So they're saying at this point A, it's 50 meters off the ground. And then if you are standing, so like this is the leaning part of the tower. If you're standing at point A and you drop a weight, it falls 5 meters away from the tower. So this is our triangle. We have our picture here. With the measurements that they have given you, what can you determine? Take a look at what's given and what can you do with those measurements to figure out.
Legs, we can, what's it called? Come on, Birdie. Just did square root them.
So we'll square root them and using Pythagorean theorem, and that means what part of the triangle are we going to find? Right, the hypotenuse. And the hypotenuse is going to end up being around the length of the tower, right? So go ahead and do that.
How was your weekend, Miss Greenville?
It was good. Productive. Started working out again. Didn't hurt. I mean, I'm sore, but it didn't hurt.
Yeah.
So I'm pretty happy. How was yours?
All right.
Just all right. Well, it's better than crappy.
We kind of got beat twice when we should have.
Yeah, I saw that.
Mm-hmm. Well, Logan home game, we got, what's it called? Cheated out on. Pretty much
What, for what sport?
basketball.
Didn't Logan on pretty much one state last year?
Well, they beat our varsity team by a lot because they had like 2 D1 prospects.
Yeah.
And then we got cheated out of our game because there was an and one and no one was even near him or touched him. I mean, someone was near him, but like
Mhm.
didn't like touch him at all. And they called a foul. And even I texted some of the Logan on guys after, and I was like, "Was that a foul?" And he goes, "They all went no."
Well, did you lose by 1 point?
Yeah.
Was it at the very end?
Like,
So
a
were there
buzzer.
other chances did you guys miss any free throws at all during the game?
Oh yeah, by a lot. We missed.
So therefore, how'd you get cheated when you guys had freebies and you didn't take it?
Well, it's called. I made all my free throws. I made no.
You
of
get
them.
my point, right?
Yes, I know what you're saying.
Make your free throws.
Well, tell my team that.
I can't, I'm not the coach.
Tell Ryan that.
I don't want to be lying. All right, so what did we get?
50.
50.24.
Right, 50.24. So
Mm-hmm.
we'll just say that the hypotenuse is around 50.2 meters using Pythagorean theorem. Okay, so we now know that, I'll put it up here. This is 50.2 meters. All right, so we figured out the hypotenuse with our given information because we had 2 sides of a right triangle. Well, can you figure out what this angle is? Meaning they want to know what it's leaning at. So can you figure out the measure of this angle with your given information? What do you think? Hey, Brody says no and yes. Shout out answer. I don't know what you know. I mean, I kind of do, but right. What do we think? Can we figure out that angle or not?
Yes.
Yeah.
And if you ask me why, I don't know.
Yeah. How? If you say yes, then how are you gonna figure it out?
We already got one side. We already got the 90-degree angle.
Well, you have a 90-degree angle, but you're missing 2 angles. So can you necessarily find that angle without 2 angle measures?
No.
No, right? Because all you guys know at this point is the triangle angle sum theorem. And you need at least 2 angles to figure out the third. But trust me, by the end of this chapter, if you pay attention, you will know how to solve this. It's called trig.
It's called paying attention. Like you're doing anything.
Like trigonometry?
Yeah, trigonometry is this chapter. Okay, so like I said, at the end of this section, you're gonna know how to find that angle, given that it's a right triangle and that you have at least one side and a given angle measure, or you have at least 2 sides and you need to find an angle measure. Okay, so the lean of the tower, right, is the hypotenuse. Is there anything that you can tell me about that hypotenuse? Or is there anything you can tell me about the lean of the tower? Like, describe it to me. Without saying the length. Well, what about if it was in terms of slope? What kind of slope is it?
Negative slope. Positive slope.
Positive, right? If you take a straight line and you go from left to right, if the line is going up, then it's a positive slope. So this one's positive. What is the slope of this line? By definition, it's change of y over the change in x. So which value is our y value? Right, the 50, because y is up and down. What's our x value?
5.
So our slope is 50 over 5, 10 over 1, or it turns out to be 10. So you could say it's a positive slope of 10, or 10 over 1, whatever floats your boat. Okay, so now we're going to build upon this idea of slope and using slope triangles, which you guys should have been introduced to last year.
It should have been.
Yeah, I already asked my classes. They said they had it last year.
Okay. I don't know.
Ah.
I don't remember anything from that class.
So, in order to find the angle we're gonna look at these slope triangles. So slope triangles are just triangles that you build off of these slopes. So, like, if I have, I don't know, this line right here, right? Every line has some sort of slope. I'm gonna move this back so maybe they can see what I'm drawing. I don't know. Kinda. You don't really need to see the board.
Is there anybody watching right now?
So I have this line right here. Let's say you're like, I don't really know how to do that, but or to find the length of some point, whatever. But you can make a slope triangle like this to find the slope of this line. So you would just find out like how many spots did we move down, let's say 3, and how many spots did we move over. So therefore the slope is 3/5. So the hypotenuse is always going to be our slope ratio in this exercise. So looking at the first triangle, what's our slope? What's the change in y?
1.
And then the change of x.
5.
So therefore the slope is no decimals. We don't do decimals in slopes. 1/5, right? So the slope is 1/5. The slope angle is 11 degrees. You just know that right now. The slope angle is always going to be the line that's a part of the slope that connects with the x-axis. So that's the slope angle. You're also going to see it written in terms of this guy right there. So theta, that's just some random, it's just like an x. Very cool. Whatever.
Or a guy with a hat on.
Well, I mean, I kind of made it fancy.
Okay. Elf.
It's the Greek letter theta.
No. Looks like a ninja with a headband.
I guess. So
And a smiley face.
if our slope triangle has a slope of 1/5, you need to make 3 more triangles that are similar to that triangle. So they have the same slope, but they are not the same size. So you need to use the graph and draw 3 more triangles that have a slope of 1/5, but are not the exact same triangle as that one.
Wait, what? You have to draw a what? You draw a what?
3 more triangles that have a slope of 1/5, but can't be that exact same triangle that we have. They need to be bigger.
So it could be like,
Okay, well, let's think of it this way, right? From this line, you have to start, remember how you have to start where it's all nice and pretty, it's at the crosshairs?
Right.
So this one, we started here, and we only went down 1, and then we kept going until we met the line again. So let's do it 1 more than 1, which would be what?
2.
2. So if I go up 2, I keep going until I get to the line. So this side is 2, but what's this one?
-2, 3.
Not negative. Can't have a negative length.
9.
Keep going.
10.
Right.
it's 10 because 1 times 2 is 2 and then 5.
Perfect. That.
See, I was gonna do that, but I tried to do it on the bottom and I just couldn't get like
That's okay.
10.
Yeah. I had to do it. I had a hard time drawing it. Like drawing's my thing. I don't know. But I just didn't like it. So our original change in y over x is 1/5, correct? And then since these are going to be similar triangles, the sides have to be what?
Same. Well, same.
P. Keyword. Same angles, the sides are
Proportional.
proportional. So I told you that I now have an x of 2, and you need to figure out the y. So you just would have cross multiplied. Or as Zach said, he noticed, well then, if this was multiplied by 2, multiply that by 2. So make another triangle. What would be the non-reduced slope of another triangle? So reduce means it's down to 1/5. So what could be the change of x in another triangle? We have one triangle with a change of x of 1, another triangle with a change of x of 2, 3.
That's what I just did. Was
Yeah.
three.
Let's try 3. So I'm going to go over here. Sorry. Here and go 1, 2, 3. And then over until I meet the line. So if the change of x is 3, what's the change of y going to be?
15.
15. Because this time it went from 1/5 to 3, so the y has to be 15. Because 3 times 5 is 15. Okay, give me another one.
4.
And you know what it is?
20.
Right, 20. So we had basically 4 triangles. They're not all the same triangle because they're obviously bigger in size. We can tell that because they don't have the same side measurements. Right? These are 1 and 5, 2 and 10, 3 and 15, 4 and 20. But we can find their slopes. This has a slope of 1/5. Okay. This has a slope of 2/10, which reduces to 1/5. This has a slope of 3/15, which reduces to 1/10, and this has a slope of 4/20, which again reduces to 1/5. So basically, any triangle that we draw where the hypotenuse is on the line creates similar triangles. All sides are proportional, all angles are the same. So that's why all of the slope triangles on this line have to be similar. Because all our hypotenuses are on the line. So since these triangles are similar, all of their slope ratios are what?
Same.
Right, the same. We just did it. Those
You
fractions
know, I
over
wrote
there.
that and then erased it because I didn't know if it was right.
Yeah, no, yeah, you're right. I know it seems like redundant, but it's kind of good that they did the repetitiveness. So they're all the same. So it says confirm your conclusion by writing the slope ratio as for each triangle as a fraction, and we did that over there. What's important to get, they tell you to change it in a decimal form. I don't want you to do that because I want you to always just know that slope, just keep slope as a fraction. If you change it to a decimal, people get confused on how to graph the line. All right, so then we have Tara. We're on 4-3. Tara thinks that she's noticing a pattern here, and she wants to investigate it. So she says, what if I draw a sloped triangle with this line of a change in y is 6? So go ahead and draw that.
Be 30.
Huh?
Maybe 30.
So it's
Say it again, what do they want us to draw? I don't understand.
a triangle. So we draw a sloped triangle. So it's still on that line. So our line looks like this, right? I drew it all backwards on that one. And we don't know, well, we do know that this is always going to be the change in x, and this side is always the change in y. But this time she says, I'm drawing it on the same line, and the change of y is 6. How are we going to find the change of x? I know we know the answer, but how do we find the answer? What are we comparing it to?
Yeah.
Right, the other one, right? This triangle is still on our original line. One, 2, 3, 4, 5, 6.
Doesn't even hit the line.
Yeah, it's not going to, but whatever.
You get the idea.
Yeah, you get the idea.
Draw.
Right? So this is 6. Well, how are you going to figure out the length of this one?
It'd be 30.
Okay, what do we do?
Well, I just did 6 times 5. So
Okay, how'd you know to do that?
because the first number is 1 to 5.
Right, yeah, the slope of the original triangle is still 1/5. So that's a ratio we get to continue to use.
Right.
And since this triangle is on that line, then those two triangles have to be similar, which means sides have to be proportional. We know 1 is 6. So you would just cross multiply. Or recognize what the scale factor would be, and this would be multiplying by 5. Or 6, sorry. So the reason we were allowed to do that is because the triangle was still being formed on the same line as before. So then what if we still have another triangle that's on the line, but the change of x is 40? What's going to be the change of y? Well, it's still on the same line, so isn't there a ratio that we get to use to compare it? What's that ratio? Right, 1/5. Where does the 40 go? Where?
Above, the top.
Slope is the change in y over the change in x. To the bottom. Right? So then we solve for y.
Answer's 8.
We get 5y equals 40, so y equals 8. Your first step is to realize it's on the same line, so we get to use a slope ratio of 1/5. We already have a number for the other ratio, so we get to cross multiply. But what happens if you draw a slope triangle that is not on that same line? Do you get to use the same ratio?
No,
Why not?
because it's not the same, not on the same slope.
Right, it's not going to be the same slope, so therefore the triangles aren't going to be similar. So you can't use the same 1/5 ratio. But there is a time when you can. When is that time? What has to happen? So what the question is asking, if I draw this triangle right here, can I use the same slope ratio as this one and this one? Are those the same slopes? No. Is there any time that I can draw a triangle that's not on this line but still use the same slope ratio?
I don't personally know the answer to that, but you might.
I'm pretty sure I know. Or I wouldn't have asked it. That would be pretty crappy.
I don't know the answer. Trevor, do you know the answer? Brock, do you want to chip in on this one?
I'll pass.
Ancient.
What about this triangle?
Yeah, because it's the same, like,
Keep going.
same type of angle.
Same steepness, right? Like slope is steepness. So it's if I continue on with this line, it's the same. If I could draw straight, it's the same steepness. But is it on this line?
No.
No.
But does it have to be?
Ooh, does it have to be?
I don't know. I'm just asking.
That's a good question. Does it have to be?
I don't think so.
No. What kind of lines are these?
Parallel,
Parallel. And what do we know about lines that are parallel?
they are congruent?
So, no, doesn't automatically mean they're the equal length. Congruent means equal in measure. Parallel just means that they never intersect. We got,
So they're straight, so they never.
right, they're gonna continue
Right.
on forever.
Yeah.
Let's say the slope of this line is 1/5 x plus 2, and the slope of this line is 1/5 x plus 7. Immediately, I can look at those two equations and tell you, if you graph these lines, they are parallel lines. How did I know?
Because they have the same slope.
They have the same slope. So if you have two lines, let's say your question just does this, and it tells you the slope of this line, well, you now know the slope of this line because they told you they were parallel. So parallel lines are always gonna have the same slope. So that's when it works. Why are you guys so tired? You
I
do
was
some
up at 5.
jumping jacks?
I was up at 5:30.
Oh, boo-hoo, so was I. I wake up at 5.
Sometimes I wake up at
Why are you
4:30.
guys up at 5?
I
In
gotta-
the middle of the night.
I gotta go to work.
5:30.
Why you wake up
I
at
get-
5?
I gotta get here and do work.
Girls take long to get ready, bro.
I
I
gotta
don't
do
really take-
makeup,
I-
shower,
No, I
hair.
didn't really do anything. I do my eyes, that's all I do.
Well, I mean, we wear a mask all day, so I don't
Yeah, I'm
really
not-
think it matters.
I don't know the last time I wore like face.
Yeah, I don't even have to brush my teeth.
5:30, wake up for a run.
You're the only
Oh, that's
For a run.
gross, bro.
Too much information.
No, I got to
Whoa.
because I wear my mask on my chin, so.
You don't smell it?
No, I brush my
Oh.
teeth. It was a joke. I got
Oh.
braces on. I don't have a choice.
Oh yeah, true. Alright. So what about if we draw the triangle on a different line? So we have our first triangle. Let's keep that one going. Let me draw it prettier. Alright, so our first triangle that we were introduced to today looked like this. Had a slope of 1/5, and it had, so let's do this. So it had a slope ratio of 1/5. I don't know why I call it slope ratio, I guess so that you realize it's a ratio, but do you guys realize ratios are fractions? Hopefully by now. And then it has a slope angle of 11 degrees, so that right there. So that was our first triangle. Okay, so says what happens if you draw your triangle on a different line? We're going to investigate that. So on the first graph, you need to graph the line y equals 2/5 x.
So y equals 2/5.
Yep.
Ooh.
Graph it. Come on, let's go. Graph the line.
I'm done.
Chop, chop.
Mm.
Gotta know how to do these.
Mm.
We're in the back room.
Where does this line cross the y-axis?
Ooh, hold on. 2/5, isn't it?
Up 2 over 5, right?
Yeah.
Where does it cross the y-axis at?
It's drive and fly. So over 2 up 5, right?
Up 2 over 5.
You have to like, you have to ride the elevator before you get out.
I always learned to drive, then fly.
How do you go through the, I don't understand.
Just do it backwards. I act like you're already on it.
Oh,
Well, you can't drive and fly. You gotta fly and drive.
right.
See, that's
wrong.
so you're the
Yeah,
drive.
get to the airport.
So the drive and fly is for when you're graphing a coordinate.
Yeah, I learned that like 3rd grade.
But
so
we're not
yeah.
graphing a coordinate. We gotta do slope, which is the other way around. So when we graph a line, we want to usually see it in this form, y equals mx plus b. And it is. M represents the slope, b represents where it crosses the y-axis. So where does this line cross the y-axis?
At the origin.
At the origin, right? Since there is no number here, it really says +0. So we get to start at 0, 0. This says move up to over 5. So So if I graph the line, looks like this, and I'm gonna go ahead and make a slope triangle where the height is 2, the base is 5. Yours could be bigger, it's fine.
So it's actually over 5 and up too.
If you wanted, yeah, I just rather you not say it that way.
But look at it.
You go, it's rise over run. So you had to rise.
So instead of going over 2, you go over 5?
Yeah, the top number tells you how many either to go up or down. It's a change in y. The y-axis is the vertical one.
Right. So
So I had to go up to over 5. Because it's 2 over 5. All right, so what's the slope ratio for this triangle?
Michael's.
That's the line. I want to know what's the slope ratio.
Oh, 1 over 5.
2 over 5.
2 over 5.
What? Oh, that's for the other one.
Yeah. So the slope ratio is 2 over 5.
You don't know the angle of it.
Yeah, you do.
What?
What does the slope angle up here to be? Use previous
11.
knowledge. Well, if it's a slope angle of 11, then the slope ratio is 1/5. Is this the slope ratio of 1/5?
12.
would I have to?
So you're saying if I move this up one whole unit, then it only moves it 1 degree?
If you move which one up?
This line right here.
Oh,
Because this 2 went up, right?
right.
On 1.
What would it go up then?
We went from 1/5 to 2/5.
That's 20. No.
How do I go from 1/5 to 2/5? You multiply by 2, which is the same thing as adding another fifth, right?
22.
So doubling this, which would make it 22 degrees. There you go, good job. So it's around 22 degrees. So if you now, that's our second triangle. If we have a slope ratio of 2/5,
Oh,
the
so
slope
one.
angle is 22
Now I
degrees.
understand. So
Yeah.
1, 11, 2, 22.
We're gonna skip B because I'm lazy and didn't get out the protractors. And you need to go ahead and go to C and graph the line y equals x plus 4.
Huh?
Graph the line y equals x plus 4.
Ow. Yeah, right?
This is.
So you ride the elevator before you get off.
Well, yeah, but we have a y-intercept now. What is the y-intercept?
That's the one. This one.
Well, what number is representing the y-intercept?
Thanks.
That's a slope.
4.
The 4. So you have to plot the point y equals 4, and then start from that point and ride the elevator.
But then you don't have to slow.
Yeah, you do. So
Over
we
4.
got on the elevator at the 4th floor because this told us to.
Where we going?
What's the slope?
So 1.
1, right? The number in front of x is 1. So we gotta go up another floor and then get out of it.
So X equals 1. That's just basic.
So I have I have a slope of 1 over 1, right? So the change in x is going to be 1. The change in y is going to be 1. I said it backwards, sorry. So what's my slope ratio,
1, 1.
right? So I'm just going to write it as slope ratio of 1. But now we need to figure out the slope angle. Bummer. That 1/5 isn't really gonna help us, is it?
No,
Kind of. How do I go from 1/5 to 5/5?
Four
Huh?
more fish.
Yeah, you could add 4 more fifths. Or we can think of it this way. Right now I'm sitting here with this triangle. Right? Well, let's say I reflect this triangle over its hypotenuse. So what shape do I have now?
square.
Square, because these two sides are 1, so therefore these two sides have to be 1. This hypotenuse is now a diagonal of a square, and by definition of a square, diagonals bisect the angles. Definition of bisect means it cuts something into 2 equal pieces. So we know that a square has 4 right angles. This is going to be our slope angle, which is now what? The 180 can't be 180. 180 degrees total in a triangle. So if it's 180, it will be a triangle. Well, what's the measure of each angle in a square?
45. Wait,
Yeah, it's gonna be 45, right? Because they're each 90. I just told you that a diagonal cuts the angles in half. So this is now a 45-degree angle. What?
I just.
Let's go to just back to this. So a square has all equal sides, right? And it has 4 right angles. A diagonal goes from one corner to the opposite corner. By definition, the diagonals bisect the angles. The definition of bisect means it cuts things into 2 equal pieces. So if this line cuts these angles into 2 equal pieces, they have to be 45 degrees each. If we erase this part, we have our right triangle that we already had, which makes that degree 45. Which makes sense because this is a scalene right triangle. So if these two sides are equal and 90 degrees is already used up, we just divide it by 2 to get that 45. Okay, so I'm gonna give you guys charts tomorrow because we have to kind of start using these. These numbers are important, that's why I have them up here. So slope ratio of 1/5 comes down to 11 degrees. So if you have a triangle that's 11 degrees, has an 11-degree angle, then you know the slope ratio is 1/5 and vice versa. 2/5 is 22 degrees and 1 is 45 degrees.
So if it's 1/5, it's always
The slope angle is always 11 degrees. So my question is, do you think that it works for us to just keep having a continuous list of all of these slope ratios and slope angles? Like, do you want to carry around tons and tons of papers and looking up like, oh, okay, I need to find that angle? No, right? So there's something that we're going to develop yet to help us out, and we won't see that until after we get back from Christmas. But I just want you to know it's coming. There's an easier way.
Or we
At
forget
least I think it's easier.
everything.
Huh?
Or we forget everything over Christmas.
Well, that's why it kind of comes at a good break because if you forget how to do that, it's fine.
Oh.
All right, so let's do some true or false. All slope triangles have a ratio of 1/5.
False.
Why?
false.
Why?
Because it
Yeah,
literally
Proofs
says
on
it.
the board, right? If they're not drawn on the same line, then they're not going to have the same. They could possibly not have the same ratio. If a slope ratio is 1/5, then the slope angle is approximately 11 degrees.
True.
True, right? We already figured that out. If a line has an 11-degree slope angle, then the slope ratio is approximately 1/5.
True.
True.
Right? These two are the same. They're just converses of each other. Different lines will have different slope angles and different slope ratios.
Yeah, I
Always,
agree.
always true.
Not always true.
Okay, when's the time that it's
From the line
True.
back there.
right? When the lines are parallel. If the lines aren't parallel, then this statement is false, right? If we don't have parallel lines, then we have different slope angles and different slope ratios. So
I forgot about that until you just said something.
it's not so important to have that stuff memorized because we are going to learn the method, and you'll also get sheets to help you. What is important? All of the stuff that we are learning in this chapter only works for right triangles. Another thing that is important, your hypotenuse is going to be what is referred as your slope ratio. So you need to know that. Look up here. Up here. This stuff is what I'm pointing out right now because last year was a complete failure with students memorizing this stuff. So hypotenuse gives you your slope ratio, which means your slope angle is right here. Your slope angle is going to be the hypotenuse and the change in x. Hypotenuse, change in x. Also important to know this side is the change in x, this side is the change in y. Okay, so I would start labeling my right triangles as slope ratio, change in y, and change in x. Okay? Alright, so like I said, your homework tonight is the Ed puzzle with the lady on there teaching 4.1.1.
40 minutes long.
I feel like it's not. Hold
You
on.
have to answer questions in the middle of it.
But it's like